Hello, I'm Satoru with just Sigmund from Class 612, number 7.
Hello, my name is Chayapol Naruntarangu Naitaya, number 14 from class 612.
Hello, my name is Gerard, number 10. Our group will be presenting about carboxylic acids, basically a homologous series of compounds. Homologous compounds mean compounds of similar chemical properties. We'll be going over the atoms, naming schemes, characteristics, and applications. First off, characteristics. They are basically, the carboxylic acids are an organic compound group consisting of CO, which is carbonyl, and OH, hydroxyl. Combined, you get COOH. And the general formula is RCOOH, with R being an organelle, such as acyl or acanil, for example. In addition to this, it being a combination of both also means that some of its properties are because of being a combination. Some of its properties are influenced, basically. Some of its notable properties are like its strong odor, its similar boiling point to water, although that's dependent on carbon atoms, and it's being a weak acid that doesn't fully ionize. In addition, the structure is planar due to the sp2 hybridization of the carbon atom, and the acids can also form dimers. You can see it on the slides here. Next, nomenclatures or naming schemes. I don't know how to pronounce that. Carboxylic acids end with oic, such as methanol being methanoic and ethanol being ethanoic. This functional group has the highest priority over other functional groups and overrides them, basically, if it would end in oic. Anyway, finally, there's also some common names for specific carboxylic acids, such as formic acid for methanoic acid and acetic acid for ethanoic acid, for example.
Now I'm going to talk about the properties and characteristics of carboxylic acid. And we can see that carboxylic acids are more acidic than the other member of the homogeneous group because of its resonance stabilization of the carboxylate anion formed upon deprotonation, but they're still weak acids because they have pKa values of around 4 to 5. Electron withdrawing groups can increase its acidity by stabilizing the carboxylate anion, while the electron donating groups can decrease its acidity. The boiling point of carboxylic acid is that it has higher boiling points than alcohols, ketones, or aldehydes of comparable molecular weight because of its ability to form hydrogen bonded dimers. Hydrogen bonds significantly increase the boiling point because it usually has the highest bond strength. And its solubility is that carboxylic acid are very soluble in water because they consist of hydrogen bond, but if that carboxylic acid has a very long alkyl chain, the solubility in water decreases because the polarity decreases, but it will also, be more soluble in nonpolar solvents. Now I'm going to talk about the reactions involving carboxylic acid. And first off, I'm going to talk about how carboxylic acid is formed. Basically, one of the ways that carboxylic acid can be formed is through the oxidation of alcohols or aldehydes. Primary alcohols and aldehydes can be oxidized to produce carboxylic acid using strong oxidizing agents like potassium permanganate or chromic acid. Through strong oxidation, alcohol can be formed into carboxylic acid right away, but through slight oxidation, alcohol will first turn into aldehyde before more oxidation occurs, which will convert the aldehyde into carboxylic acid. Now, I'm also going to talk about the reaction involving carboxylic acid. And first off, I'm going to talk about the esterification reaction, which is when carboxylic acids react with alcohol in the presence of an acid catalyst to form esters, which is useful in perfumes and industrial applications as well. And there's also reduction to alcohols where carboxylic acid can be reduced to primary alcohols using lithium and aluminum anhydride. There's also the amidation reaction, where carboxylic acid reacts with amine in order to form amides. And there's also the decarboxylation reaction, where carboxylic acids can lose carbon dioxide upon heating, especially if they are beta keto acids, or if heated with soda lime, they can be converted into ketone and form carbon dioxide gas as well.
Next, I will be talking about the industrial applications of the carboxylic acids. Firstly, they are used many in polymers products. Carboxylic acids can be used in making many important polymers, such as polyesters and polyamides, easily called nylons. They are also used in biopolymers and coatings as well, due to the presence of the polar group that helps solvate in the aqueous system, facilitating its processing. Next, they are used in pharmaceuticals. Many drugs are carboxylic acids or their own derivative, including non-steroidal anti-inflammatory drugs, or easily naming like ibuprofen or aspirin. Lastly, they are used in food industries. Carboxylic acids like acetic acid, easily called vinegar, and citric acid are widely used as preservative, flavorings, and acidulants, and the carboxylic acids can be also found in many ingredients of cooking like lemon, lime, or spinach. Next is the assessment. The first question asks that what groups make up the carboxyl group. The answer is they are made up from combining from two groups, that is carbonyl group and hydroxyl group. And the next is the naming the compound above. The name is 4-hydroxypentanoic acid. And lastly, what is the IUPAC name for the acetic acid, or easily called vinegar? Its name is ethanoic acids. Thank you for your listening and attention.